Today I'm talking about Perl 520. I lied in the discussion and said I was going to have a retrospective of 20 fantastic years of Perl 5. Forget that. I'm just going to talk about all the cool new stuff in Perl 520 because it's awesome and it makes everything else in Perl seem like crap. Okay. First of all, experiments. We added this idea of experiments to the Perl documentation a long time ago. And the way it works, the policy is sometimes you bury in the documentation a note that this feature is experimental. And then 15 years after no one has used it, you try to remove it and you find out someone has built their business on your crazy experimental feature and you cry and you cry. So in Perl 520, we've changed this. This is the only policy thing I want to talk about because it matters to your day-to-day use of Perl. There's a document called Perl Experiment, and it lists all the stuff we think is experimental. And if a feature is experimental and you use it, we issue a warning. We've started adding those warnings retroactively. So in Perl 518 and Perl 520, you start seeing warnings saying, hey man, you're using an experimental feature. From now on, any new experimental feature is going to get that warning, and you have to turn it off. And you should consider adding the line that turns off that feature. That's your signature on a waiver, saying, I know that you can change this and remove it, and I promise not to complain. Remember that part, please. You promise not to complain, because we're trying to bring out cool new stuff, but we don't want to get hamstrung by having to get the design perfect to begin with, or by having people become really attached to the things that we later decide have to get yanked out. So the experiments are new things that we're trying out. They might not stick around. They might change the way they work. Don't build your business on top of our experimental features, but use them, try them out, and tell us, what is awesome about them, what is busted about them, so we could get them just right before we take away that warning. We retroactively added experimental status to a couple things. I promise we will not do this again. But because we've been adding features with no experimental process beforehand and no testing out of the design other than potentially a very brief period in development, we've added stuff that's kind of a big hot mess. For example, Smart Match has been marked experimental retroactively. Smart Match is going to change, I hope. If it doesn't change, it's keeping that experimental warning forever. Also, lexical subroutines, my, sub, something, those are a current experiment. And automatic dereferencing, where you can say something like push $arrayref, that's an experiment. That's probably going to come out at some point. When you use an experimental feature, something like given when smart match stuff, if you try using this in Perl 5.8 or even in Perl 5.20, if you just write this code, you get an error. It says, by the way, we are on an interesting color scheme here that does not look anything like my slides. I don't think it will matter. The syntax error. Why? Because you haven't turned on the feature. Some features need to be turned on. Hopefully you know this by now. If not, read Perl doc feature. You turn them on with feature. You say, I want to use the switch feature, and that's great, and it works, unless you're using Perl 5.18 or later when we've made it an experiment. And now it says, oh, that's experimental, you get a warning. Okay, so you fix that, and you add no warnings for experimental smart match. Great, no problem, you've turned on the feature and turned off the warning. But then you try running your code on Perl 5.16, which didn't have that warning, and now it's fatal again, saying there's no such warning for that. So you have to say, okay, I want to turn the feature on and turn the warning off as long as the warning exists. So you say no if right bracket greater or equal than 5.18, right? And now you're back to crying again. So we've put into Perl 520 a module called experimental. And if you want to use an experimental feature, you say, I want to use experimental smart match. It turns off the warning if it has to. It turns on the feature if it has to. It tells you that you can't use it on your version if it has to. And it's just one line, but it still constitutes a legally binding promise that you're not going to complain. Okay, enough. Let's go on to cool stuff. Postfix dereferencing. Oh, I'm so happy. So you've got a thing, some session, and it's a hash ref, and in it you have an entry. And the entry is an object. So you can call a method, and the method returns an array ref, right? Great. So your job is to record a new login onto that array ref. So what do? You push onto the session's users' logins, the login. This won't work because you can't push onto a scalar. You have to push onto an array ref. So having written that code, let's write that code again. Push onto a session's users, logins, the login. This is how we write in English. We write from left to right. Great. Except then we need to go back and add stuff around after the fact because we didn't realize until then, oh, there's no red in this projector. That might be a problem. Okay. there should be a circumfix dereference right here. We need to fix that for the next guy. Now, in 5.14, you can omit those. Now, what this slide looks like without those is this, OK? And that's going to work because you can push onto a reference in 5. Yeah, I've done it. So you can move back. If we could fix that during this talk, it'd be great. Oh, wow. OK. So you can do this. What you saw, the same slide, you can do that while you're doing this. You can push onto an array reference, and it will work in 5.14. In 5.20, you're going to start getting a warning saying, maybe don't push onto an array reference. The problem is, I'm just going to go off slides for a moment here, because what's up with this? The problem is, OK. So the problem is, you can push onto an array reference. Let's pretend that the feature didn't become experimental. You can push onto an array reference, and that'll work. You can shift from an array reference. You can get the keys of a hash reference. It all kind of makes sense, but only in a very limited set of circumstances when you're using one built-in from a small list on a reference, and only in some ways, right? So it was no problem to push onto this reference. There's no circumfix there. We're going to push on something from a queue, and it's the unflushed things of the queue. It's the logins. But it turns out that logins itself is also a reference. We can't automatically dereference that because it's ambiguous, right? Do we want to push on the array ref found in logins or the elements in the array ref? It's simply impossible to intuit, for the compiler to intuit whether we're trying to push the elements from the array ref or the array ref itself. So automatic dereferencing can't solve that problem. It leaves us back with these horrible, invisible circumfix dereferencing. Also this kind of guy, right? Do we want to call a subroutine on the array ref of jobs or the jobs in the array ref? Everybody could just gather around my laptop. No? So that's going to be a problem, because we don't want to have to write this ugly circumfix. That doesn't help either. OK, so we don't have this circumfix operation. And if we map, boy, that's just terrible. Shucks. Yeah, it's been wiggled. Jankled, I believe, is the technical term. So what we've got here is we've got some array ref. We've got a circumfix dereference that. And here, what you don't see is the $, because we're actually trying to get the last index of that array. And the $, when we're doing it on a reference, also has to become circumfix dereferenced. OK. So what we can do, now this is OK. Yes, thank you. Adding some red to the slides. So what we're going to do is stop thinking about automatic dereferencing and stop thinking about circumfix dereferencing. Circumfix operations are a necessary evil, but they're not always necessary. What we can do here instead is say this. This is new syntax in 5.20. You can dereference something strictly going left to right. And it doesn't just work for someplace like push. It'll work anywhere. So for example, if we want to dereference that last thing, the queue unflushed logins, we can postfix dereference that. And it works everywhere. If we want to do it on the jobs that we're passing in, we write that. If we want to do it here, we do this. And we can even do that. Any kind of circumfix dereferencing expression, we can turn into a postfix expression. Now, some people are going to say, well, they're not very pretty, are they? Now, first of all, neither was circumfix. And secondly, it's Perl, right? People making arguments about beauty of the lines in Perl they're in the wrong room, OK? And by the way, it is beautiful anyway. OK, so the way this maps, let's see how this slide looks. The way this maps is, OK, guys, we're going to switch. We're do it live. No, it's about the same. OK, so anything that you wrote like this with a circumfix at braces, you can turn into that. It works for hashes. It works for scalar dereference. It works for subroutine dereferencing. That is not a subroutine call. It gets you the subroutine that is being referenced. You can do it with globs. Great. And you can do it for this guy, who is not often thought about. But I'll tell you what, the thing on the left, to me, is still a lot more confusing than that guy on the right. And it doesn't just work. Well, let's go back and see this again. It doesn't just work for this. It also works when we're taking slices. So if you've got an expression that returns an array ref and you want a slice of its values, you can put it on the right-hand side. You can do the same thing with hashes, hash slices. You can subscript a glob with this. And now you're not going to be doing this every day, but in those cases where you have a glob reference and want to pull out one entry, this is like a crazy improvement to the readability. You can do it inside of strings. So the point here is anywhere you used to use circumfix, you can now use postfix. And I encourage you to, because it's much more readable and writable. You can do your scalars in there. All right. So that is postfix dereferencing. I'm super excited about postfix dereferencing. One thing to note, though, is that it is an experimental. It's an experimental feature. Imagine a large red word is just dropped onto my slide. This is punishment for me not thinking about colorblind audience members. So you have to say use experimental post deref because we might get rid of the feature. Now between you and me, and camera don't look, we're not going to change this feature. Okay, it's great. Don't build your business on postfix dereferencing. And if you do, tell me how you did it, because I want to know. OK, moving on. Let's do some smaller stuff. Optimizations that are good. So every release of Perl, we try to make faster, and in some ways, we often succeed. One of the things that has been added is a copy on write optimization. The copy on write optimization is it could be a whole talk in itself. All I'm going to say is this. Here's a business critical program. OK, we've got what I call a mega X, and we're going to megafy it. So we're going to end up with some very large number of x's in a string. And we run this TerraString program in Perl 5.18. And this takes, anybody? Takes about a minute, right? Whoa! If you run the same program on Perl 5.20, it takes 1/10 of a second. Now, many of you are not yet building your businesses on terrification of x's. But if you're copying around email bodies, file bodies, you're copying the strings around, you're passing strings to subroutines, which, by the way, means you're copying them most of the time. This is going to make stuff a lot faster. OK, how about these? Who can tell me which of these checks is faster? Oh, what I haven't made maybe clear enough is this is Latin letter small y with diaresis, and this is Latin small letter y and then combining diaresis. Does that help? Yeah. Well, the first one is faster because the optimizer sees this character that doesn't fit in one octet, and it says, I can't optimize any of this at all ever. And it gives up. That's been fixed because that's stupid. OK, how about this one? Which one of these is faster? I don't even know. But one of them was, which is ridiculous. So we fixed it. I'm pretty sure we made the slow one faster and not the fast one slower. But remind me to check. We've been working on our cross-compilation system. So it's gotten a lot of overhaul. And you can start working on more cross-compilation. Our cross-compilation architecture has been nuts forever. But one of the great things about 5.20 is you can build it out of the box on Android, which is really cool. And I've seen people who are now running Perl on their phones. I don't know what they're doing with it, but I bet it's pretty cool. We didn't just want to target Android. We don't want to be seen as partial to one platform or another. So we've also targeted the other main mobile platform these days. And you can run Perl anywhere. We've also got major upgrades to the Unicode system. We've gone to Unicode 6.3 from 0.2, so that's a pretty great change. You can imagine the stuff you get. Here's the kind of stuff you get in a point release of Unicode. You get this guy. Who knows this character? Anybody? Hands? Not everybody at once? How about now? Yeah. This is the Mongolian vowel separator. And we have fixed a critical case comparison bug with the Mongolian vowel separator. We've also fixed flattening of the case of a diaresis that stands alone. Very important bug. And the bidirectional paired bracket system. Who knows about this? Yes, Damien knows. This is great. This is actually great. OK, OK, the bidirectional paired bracket system is something that's been added to Unicode for the sake of languages that work in, well, we'll find out soon. Let's see, where's some red? Yay, thank you. All right, let's take it from the top. OK, so the bidirectional paired bracket system is a way for languages that go the wrong way to have their parentheses still match. Right? You can imagine that if you're writing your language left to right or right to left the wrong way, then the opening and closing parentheses no longer look like they're opening and closing. So now instead of being enclosed in these nice round parentheses, you've given your text some like radar dishes on the side. So the Unicode Consortium has set up a data file that looks something like this. It says, here are opening and closing, but don't worry about whether they're opening or closing. Just worry about the fact that they are pairs. So one pairs to the other in each case. Now, why is this actually interesting for Perl? Right? It's interesting if you have to do internationalization of your program. Well, so imagine you've got this pair here, and we can tell from the table that they're a pair. That means that we can use that to figure out that you could write this. And if we know that about the bananas, we're going to know it about the crazy Japanese quotes and let you start writing things like that. And you can start using any crazy character that happens to have a mirror image pair to bracket your quotes. It's like you'd be writing Perl 6, except for all the good stuff. Now, to be fair, we haven't actually implemented this yet, but we've made it possible, so that's something, right? I'm really excited about having this in place, and we are definitely going to try working on that. Also on the Unicode front, we have just upgraded about a month ago the development version of Perl to Unicode 7, which gives us really vital characters like these. The character that everybody has been talking about is this guy. Anybody know the name of this character? That's Rude Boy. OK, so who can spot the bug? Right, the precedence error. So we've added a warning. Right? If you have this code up top, you're never going to die, even if the return value is false, because you've returned before the OR fires. And so we added a warning, and I can imagine that you're all thinking there saying, if I'd looked for 30 more seconds, I would have seen the bug. I don't write this bug, and if I had written the bug, my tests would have caught it, so I guess that warning is fine for some people. Well, someone went and they smoked all of CPAN to see who had this bug. I present to you a subselection of that list. IO all, IO async, JSON, DBIX class, Perl critic, IO socket SSL, parse CPAN, Mason, DBI, test more. So the short version here is you have this bug, and now we're going to tell you about it. Locale. Who uses locales? Good, good. They're terrible. But we fixed this bug in the case that you might be using locales, or someone else in your operating space of your program is using locales. The radix character no longer leaks. Why is this interesting? So here's a Perl program. And we have got a number. This is what we call a number with a decimal point in it. And when we are done, we print that number. Now, the important thing to know here is that locale, which tells your program to respect POSIX locales on I/O, has a lexical area of effect. Okay, it's only supposed to operate within those braces. So what should this program print out? 1.234. What does it print out? This. 1,234. Because the effect of the locales on numbers leaks. And it gets better because that doesn't have to be in your program. It can be off in a distant package somewhere. So what you actually see is that you write this program, and suddenly commas are coming out. And so that's pretty stupid, and you might be able to track that down. But when you won't track it down is you're not just printing, you're sending across the wire some JSON of your data. And now you're sending this, which is no longer valid JSON. So the remote starts issuing you 500 errors, bad, or 409s, whatever, 408, bad request, whatever. Your remote starts erroring. So now you're trying to figure out your protocol error. And even better is if you weren't sending some object across the wire, but some array, because now you're sending this. So instead of sending across your 3 numbers, you are suddenly sitting across 2 of your numbers and 2 numbers that seem to have been plucked from the luminiferous ether. Who knows what happens then? Well, that doesn't happen anymore. So, huzzah. So, we got a program. And the program tells us the status of all our hosts. This is Ansible or Puppet or Chef or one of those things. And what do? We're going to write another little program to look through these because we are all closet sysadmins and we want to be able to use Perl to track our data. And we write a program that looks like this. It gets a line, one of those lines, and for each line, it's supposed to split it, because we've said here it's split it on commas, and then print out something like, my host is angry, or my host is up, whatever. Yes, I can count. So what does this program print out? I'll give you a hint. It doesn't print the right thing. It prints the wrong thing. Very good. Yes, it prints is. What? But we've got input. The input works. Why did it do this? Well, it's because you forgot -a. -f tells it what character to split on, but -a tells it to split. Right? Gotcha. So we fixed that, and you don't have to remember all the dependency tree of your command line switches. If you pick one at the bottom, it gets the one at the top. Great. We fixed rand. OK, rand, it still sucks. Rand gives you pseudo-random numbers, and they're not very good. But if you were on Windows, they were very not good. We used to give you 15 bits of entropy on Windows, 48 everywhere else. Now you get the full 48. This doesn't mean that you can start using Perl's rand for your cryptography, but it means that if you're on Windows, you can maybe stop jumping through hoops. OK, so now maybe we've started reaching the bottom of the barrel, and we should go back for something exciting. Pair slicing. I like pair slices. Here's what they are. Since the beginning, Perl 5 has had arrays, and you could get a slice of an array, something like this. And what that means is that you want to get the values at index 1 and 3 as a list. So what you end up with in slice is that. Hopefully, everyone here, who has used slices? A lot of people, right? Because they're great. Slices are great. You can do this with a hash, too. So we've got a hash, and we can pull out slices, and we get the values. So we want the values for A and C. You can tell that we want a list of values because the sigil has varied to an @ sign. And what do we get? We get 1 and 3, which are the values for A and C. What we have added in Perl 520, instead of switching your sigil to an @ you switch it to %. And what you get out is not a list of values, but a list of pairs. So you can pull out, for example, a subhash. This is a big deal. You can also pull out a list like this. And notice we're not now going to assign it into a list, into an array, rather than a hash, because we're not getting a hash out of the slice. We're getting a list of pairs. So we can pull out things multiply, and we can pull out values that don't exist, for which we'll get an undef. So why is this interesting? So I'm going to write a database to track my music, because this is the example that we use when we talk about code. And there's a bug here. The bug that you probably can't see, but maybe yes, someone's pointing at it, is that we've misspelled label. And why did I misspell it? It's because I had to type it twice. If I only had to type it the first time, I would have gotten it right. So why do I have to repeat myself? Repeating myself is the worst thing, OK? Repeating myself is the worst thing. So what we have to do, or what we can do now, is we can say, I don't want to have to say artist, artist, title, title, tracks, tracks. I just want to say, give me the subset of the args for artist, title, and tracks. And it works. Why did I stop there, you ask? Why haven't I moved on? Well, I'll tell you why. Here's your mission, everybody. You've got a hash ref in a hash ref, and you want to get a slice of its values. So there's your input, and you want to pull out a slice of the values out of the hash ref stored at X. What does it look like? Here's my first try, OK? I write this. It didn't work. I got undef. OK? I'll try again. How about this? No, now I get an exception because something's not an array ref. OK. Oh, I know. I need to move around the braces, right? Maybe it's this. And what happens? Oh, now I just got an empty list. Oh, man. How about this? OK, I got it. every time I'm slicing a reference, I do this. Every time. So I look at this and I think, you know what, it's not worth it. I'm not going to try and figure out. If only there was some way to not have to figure out all that circumfix deref. If only I could write this, but I can because we have postfix dereferencing. So you can pull out all the structures you want from this reference without having to remember where the braces go or which sigil you need, because you know at the end you need a list of pairs, and that means you end up with your percent. OK, so you can also use that on guys like this. So we had an array, and we want to pull out a list of its values. That's fine. We saw this in our first example. We can do the same thing, but switch to a list of pairs, and the pairs we get out are the indexes and the values. Yes, we believe in equality between data types. OK, that is pair slices. I'm super excited about pair slices, and I'm extra super excited about how they work together with postfix dereferencing. Pair slices, unlike postfix dereferencing, are not experimental. They're obviously correct. That's our hope. Because I promised I'm not going to go at it. Yes?
So that makes it really easy for you to take a list, turn it into a hash where the keys are basically the index of the list.
It's easy to take yes, it makes it easy to invert your list of pairs, right? Yes. You can easily take a list of pairs now and invert it just by getting a pair slice of the whole thing. OK, moving on. Bug fixes. OK, I've made a short list of bug fixes to discuss with you. My selection criteria were that they made me laugh out loud. OK, so these are mostly presented as excerpts from the Perl Delta. Compiling a split operator whose third argument is a named constant evaluating to 0. Okay, so that looks like this. We're going to split something on commas, but only up to split fields number worth of them. No longer causes the value of the constant to change. Any bug fix that says we no longer change the value of constants is OK by me.
What the hell was it doing?
Well, I'll tell you what it did. So what happens is it looks at the maximum number it could get, and it would say, right, it's got to be this, and it sticks into the constant. OK, so this is a good one. So you've got a regex object, and you use it as a test in an if. Use it in Boolean context. And then for some reason, you also want to check it having been scalar dereferenced as a test condition. The first one was true. The second one was false. Now, the funny thing to me is not that we had this bug. It's that somebody noticed. What were they doing? I don't know. But we fixed it, OK? How about this? On 64-bit platforms, large number ranges like 1 through 1 trillion no longer crash. They just use up all your memory. OK. Along with adding good stuff, one of the things that we like to do is rip out awful stuff. So this is a subroutine. I'll let you have a moment to take it in. Hopefully, makes sense. The subroutine is maybe not relevant here, although we will come back to it later. So remember how this one works. If you wanted to call that subroutine, you are beset on all sides by options. There are many ways to do it. You could call it like this. You could call it like that. There's a go-to form that I did not put on my slide. Or you could write this. Do add followed by a list. Who uses still the do subroutine form? Good, because we got rid of it. Now, why is that interesting? By getting rid of that form, we eliminated about 2% of Perl's grammar. And there was somebody who said, actually, I think we should probably keep that around. It's pulling its weight. OK, so this. Who, other than Damien, has used $H? A couple people, OK. Even Damien other than Damien. Now, what you may not know is that there's another way to write that variable, and it looks like this. Now, you might be a bit confused, because Keynote is not very good. What I've actually keyed in is $ and a backspace character. Because the backspace is Control-H. And as we all know, caret followed by a letter means control that. So for example, if you wanted to reference the variable $k, you could simply put dollar followed by a vertical tabulation.
Helps the golf.
Yes, it helps the golf. Well, it's not going to help the golf anymore. It is out. The problem was we wanted to start bringing our grammar in line with Unicode recommendations on what space means, and suddenly this becomes ambiguous because is that a space character or is it a shortcut for $k? And as Piers noted, the use case for using the literal control character form is golf. I asked Larry about this and he says, I don't know, I used to use a lot of Ticos. Okay, we're also pulling some programs out of core like the awk to Perl translator, the sed to Perl translator, find to Perl. These are all on CPAN. You can still get them. Find to Perl, the Perl to Ruby escape hatch. No, I'm kidding. We're going to leave that one in. Pulling some modules are going to be leaving core. CGI will no longer be found in the Perl core. Module build, encoding.pm. By the way, this is serious. If you use encoding.pm, I would love to talk to you later about your use cases for it. Okay, and there's one more thing to talk about. I think I have 20 minutes, is that right? I don't know, I'm just going to talk till I'm done. So the other thing, let's pretend like nobody knows what's coming. Okay, what could I be saying? What is another interesting new feature in Perl 520? Okay, so remember we talked about this subroutine? I'm really glad at this point that we have red back, by the way. Remember this subroutine? There actually is a big problem with this subroutine. Can anyone tell me what it is? Yes. Okay, Damien? Its body is twice. That's yes. Another yes. The problem is that this is stupid. Okay, at underscore is stupid. It confuses people. It doesn't make any sense. You look at it and you're like, yeah, see, there's these stupid punctuation variables in every subroutine. I told you Perl was like this. No, stick around. It's nice. So you convince the guy. You say, look. It's not that big of a deal. At underscore is the list of things. You just copy out of that, and then you don't think about it anymore. Okay, fine. I won't. That's all I'm ever going to do. But then you have to do some kind of really esoteric, unusual operation like have defaults, and it starts looking like this. And the person says, oh, wait. I thought shift took an array. Well, yeah, but the array is implicit. It implicitly shifts off the arguments to the program. What? Yeah, well, unless you're in a subroutine, and then it implicitly ships off the subroutine arguments. So, and then your programmer friend is storming away. So it's like, what are we doing? Are we writing in Fortran or something? Well, no, because Fortran had signatures. Okay, so in Perl 520, you can just write this. Okay, the light shone down from heaven, and it does just what you think, right? You can say, I want to add 1 and 2, and you get 3. If you try adding nothing, you get a runtime error, because we know that it takes 2 arguments. If you add 1, you get a runtime error. You add 3 things, you get a runtime error. Okay, so you're getting checking on these also. If you think it's okay to add only 1 number, you can do that and say, add x and y. If not given, y will default to 0. And then everything works as you expect. 1 and 2 is 3. No argument, still runtime error. But now adding 1 works. Y defaults to 0, and you get 1 plus 0, which is, checking the math, 1. Great, Perl works. Now, you might try and do it backwards and put the default on the first person, and you get a compile time error. The only thing that makes sense is for your optional arguments to come after the mandatory arguments. This is standard stuff if you've ever written in any other language. If you want, you could also do something like this. Like you could say they've both got arguments, right? Adding nothing just means 0. It's got an identity, fine. And that's great. Now, this is great, and it gets us to the point of being able to do what every other language can do. The thing, though, is that in Perl, we do like to do what other languages do. We like to steal. We like to do a little more, though. We like to walk up and see, what have they done, go to the edge of reason, and where things stop making sense and start to break down, and then we jump. And that's what we've done. Like, so for example, you can look at this code and you can say, this is actually not very efficient, because we already know that x plus 0 is x. So why are we spending all of these opcodes, there's got to be at least 3 of them, on doing the addition when we could just say the default, if no y is given, is to immediately interrupt flow and return X. Now, if it's good for the goose, it's good for the gander. So what is actually going on here? You got all the right answers. What is actually going on here? Although this looks like crazy stuff, and it is crazy stuff, it actually makes sense under the hood, and you can see what's going on because you can use deparse. Deparse will take your Perl program, and it will tell you what Perl thinks you wrote. Who here has used deparse? A bunch of people. Who uses deparse almost every day? Yes, one person, which is roughly as it should be. Yes, of course it was Damien. So here's our program, our subroutine definition, and what we're going to do is run it like this. That invocation of Perl there, by the way, is gold. When you are confused, run that. And what Perl will spit out instead of running your program is this. This is the code into which Perl has compiled your subroutine definition. It says, I'm going to die unless I got 2 or fewer arguments, and I'm going to die unless I got 2 or more arguments. Some might write this as unless I got exactly 2 arguments. But here we're getting an error message that tells us whether we have too many or too few. Then I assign the arguments into lexical variables, and then I return the sum of them. So you see we actually have arity checking being done effectively by Perl code. When we write something like this, our crazy return X immediately, if we deparse that, we get something like this. It's just totally standard Perl that you can read and understand. What's the value of y? Well, if you have 2 arguments, then it's the second one. If you don't, evaluate return X. This is actually really simple. So although signature looks kind of crazy, and I don't have any examples, but somebody asked me yesterday, so what kind of things can you put in there? The answer is the value for a default can be an arbitrary expression. I'll just let that sink in. Anything you want. So if we take this double one and we deparse that, we get this. Again, it continues to make sense. There's nothing crazy or magical here. The checking of the number of arguments that we got is what's called arity checking. Right? We know the routine must have 2 arguments, or must have between 0 and 2 arguments. And we check that. We don't let you have fewer than the mandatory options, and we don't let you have more than the optional options plus the mandatory options. So what do we do about variadic functions? Right? Sometimes the arity moves around, and it could go on infinitely, perhaps. We could write this in Perl today. And the way we write that in Perl 520 with signatures is exactly what you'd think. You just stick it in the signature block. And I don't show the deparse for this, but what would happen is the only check you need is that there is at least 1 argument, which will go into factor. You don't need to check inputs because 0 is a valid number of things to put in an array. If you wrote something like this, where the final one is a hash, there will be a runtime check to make sure that the number of arguments put into it is even. So if you pass an odd number of values and it wants to put them into a list, into a hash, you get a runtime error. And by the way, I would never actually write the code like this. I'd write that. I've repeated myself, didn't repeat myself. Repeated myself, did. That's nice. OK, yes, Pierce?
Can you default a variadic argument?
Can you default a variadic argument? Yes, you can.
Awesome.
Yes. OK, so here's one you couldn't do. Oh, yay. OK, here's one you can't write this. Because it's not going to know where to break things. This does not make sense. You can't have 2 slurpy arguments, 2 things that take as many or as few as you give it. You can only put the slurpy stuff at the end, because otherwise it doesn't know how to resolve calls like these. You and I can look at it and say, well, it's obvious that the ones called messages go in messages, and the ones that look sort of like the word address go in, well, great. And if you would like to hand compile all of my Perl code for free, let's talk after the session. OK, so let's go back to this guy. Here's a great question for you. So we've defined addition. For those of you who are not computer scientists, addition is the plus sign. And hopefully most of you have encountered it by this point in your programming career. And the question is, we make a list of summands, 8 and 6, and we're going to add them. What is the result of calling that? Any guesses? Someone says 2. Well, the answer is it might be 2 or it might be 14. We don't know. And why is this even a question? Because I was not a computer science student, but I learned that 8 plus 6 was 14. Because we look at this, it's got 2 scalar arguments, and it looks kind of like this guy. There's 2 dollar signs in there, right? We know that we want 2 scalars. And this is a prototype, old school prototype, which will turn its arguments into scalars. It takes them in a scalar context. And that is an array with a size of 2, which in scalar context becomes 2. So are we adding 2 to 0, or are we adding 8 to 6? So who thinks that we're going to get 14? Okay, maybe a third or half. Who thinks we're going to get 2? Okay, a little less than half. The answer is we get 14. And anyone know the reason? Yes?
Because it's not insane.
Yes, because 2 would be stupid. If you really want to have a prototype, you can still have one. Like, so for example, we've got code like this, right? This is like a map. We're going to call a code block for all of the inputs. And when we call it, it looks like this. And of course, we can put a signature on that, shift the bits up, and that works just fine. But you might know that if you had a prototype on there, you could write it more nicely. So how do we get a prototype and a signature? You just say, I've got a prototype. You also might notice that it's a little harder to get a prototype now. That's on purpose, okay? And now you can take that code at the bottom and write it like this, which looks lovely. One of the few times I'm being told that I'm running out of time. So in fact, I'm out of time at 10 after? Lunch is, okay, so here's the deal. You've seen all the really exciting stuff about signatures, I think. I'm going to just keep talking because I'm not hungry. If you leave, I don't care. Write the talk, tip your waiters, I don't know. Okay, so you write something like this. You've got a logger. And the logger takes an argument and it logs it, right? But you want to write a subclass of your logger. What does it do? Nothing. It's the null logger. It's for testing. You don't need the logs from that. So it's got a signature and it throws stuff away. But you don't need the message. Why would you need the message if you're not going to log it? Now, in most languages, there's a placeholder variable that you use. And what do you call that placeholder variable in most other languages? Underscore. Right. But this doesn't make sense. Now, one thing is that like underscore means the stat thing, and I don't care. The other one is you don't know whether it's supposed to be a scalar or a list that you're getting stuff. So you've got this guy, and you don't need rest. So you say, OK, well, I know the name we're supposed to use is like underscore, right? So I'll just use this. And then like your head explodes. And you say, OK, I'm going to get over it. But oh, right, we don't actually need $X either. So you write this. And then like every little shard of your head explodes. Also, this is not tenable. This is not going to work. So if you want a variable that you don't keep around that has no name, instead of using underscore for the no name, you just say, no, there's literally no name. It's a $sign. It's some scalar thing. I don't care. Make sure there's something there and throw it away. And we don't need self either, right? So we just throw that guy away too. And if we start putting a default onto message, well, now the signatures don't match. Now, something you will have to learn if you use signatures that you would already know from any other language is that if you have multiple implementations of an interface, they have to match. So you're going to have to go back here and put a default on to make sure that the interfaces match. But of course, it's dumb to say, and the default is an empty string. Why do you have to compile that empty string? That's probably taking like a femtosecond or something of your valuable time. You don't need a default. You only need to say it's optional, so you can say that. OK? Sorry. All right. So finally, if you want to say, and a bunch of stuff, I don't care as long as there's 2 arguments. I don't care if there's extra stuff. I'm not going to worry about it. You could do this. This is going to say as much other stuff, but remember, a valid value for the number of things put into that Slurpee argument is 0. So this makes your function totally variadic, but throws away all the non-named positional parameters. OK. We can deparse that. I'm going to fly through a little bit of this stuff because you might be hungry. Boop, signatures. OK, here's a review of signatures. Right? That's all the stuff. You can write a signature that looks like you think it should. You can write one with a default. The defaults can be crazy, but just maybe don't do that yet, right? Perl's reputation should just code judiciously. And And if you want to have a prototype and a signature, you can still do that with a bunch more typing. If you want attributes, you have to put them before the signature. I'd like to fix that, but in 520, it's got to go before. The errors kind of stink right now. If you violate the arity check, it seems to come from the body of your subroutine and not from the calling place. We want to fix it. It's an experiment right now. So subroutine signatures, right? Yay! They're awesome. I hope everybody is at least half as excited as I am. They're also, see, that's what it would have looked like. They're also experimental. So Perl 520 get postfix dereferencing, pair slicing, subroutine signatures, fixes for the Mongolian vowel separator. Big deal. It's available right now. Right now it's free, so check it out. There are so many new, big, exciting features in 520 that I like to think of it a lot like Perl 510, but good. I hope you enjoy it. And if there are any questions, I'm happy to take them, or you can talk to me after. I know some people want to leave. Thank you very, very much.